Oh, okay. Well, what is this? I don't even know if this makes sense at all. Have you ever seen a Lazy Susan? It's just like a bearing ring. It has the ability to like seamlessly surface rotate. Sometimes like a seamless rotation on an axis is important because you can like set up like contact plates like inside of VCRs. There's like these spinners. It's inside of like Hammond organs too, where those have these spinners with all these specific like conductive zones, and they spin. And that's like how AC current like turns motors and stuff. Is like they give like these alternating bip bop bips, and then it like slowly just like says, well, I have no choice but to use electromagnetic power to create like torrid vortex rotation. It's really crazy. I break like angle grinders. I don't know, like once a month at least I'd break an angle grinder. But it seems like power saws, they have like a bigger space. It's like laptops. It's easier to break them compared to like a desktop. You know, it's like you're not compromising. You just have a lot of space to do what you're doing. But you can use bearing rings. This thing in the background is just a bunch of mirrors, and then you can spin it, and then you get reflections. And that's only a flashlight like pointing at it. But when it hits a wall, you could just set up sensors on a wall and then spin an actual tangible object. You could totally like separate the concept of like you're making art from like you're making an electronic sensor that receives art, and that art could be light art in this case. These are also on bearings. It's just like a rotating thing with plastics, but it's a musical piece too. This thing is a scooter wheel, and then you can just kind of like bar-esque clamp a piece of steel on it, and then kind of ratchet it closed while it's getting welded or bolted. And then these are just like welded like W's that go out in different directions. And this is like the fixture. I welded all these forks that had welded on like bolts on the top of them, so that you can put the bolts through the holes that are already in these police cones, and then just screw them on the other side. Because a lot of times you'll find materials that just have a format, or they have their regular machining, and you just have to clone or imitate it. Back when I was here at UCSC years ago doing an undergrad in like philosophy, I took a lot of Elliott's electronic art classes for fun, and I made this bodysuit just hanging out in like the crosstown these aluminum silos that we have here. And so this is like the hand gesture. They're in here still. It's like 8 or 9 years old. But it's like data pins. So all it is just 2 pieces of copper laminate board that have just been airfoiling fiberglass scissor cut into these little specks. If you look closely at these ones, actually will probably shatter with lower quality machine tools. But if I were to do it differently, you can make them smaller. You can use, instead of stereo wire, you can use like filament wire, but you gotta make sure to put kind of like chain breakers on all your wires, because if you're doing something that's kind of kinetic, it's going to move the wire, and if the wire's moving, it needs to have a stop in it. And that's usually when you like open up a VCR and you see that there's a knot in the wire. Yeah, and it might do something electromagnetically, but more to the point, it just keeps it from yanking out, because leads are expensive. So that's the data glove. They're kind of cool. And it was like an umbilical wire that went down the back of my suit and then out through the tail. So I have like flex sensors on my underarms and my interweenuses. And over here, those data pickups. You just put a little offset foam, and then you see that's like positive and zerotive or whatever it is. I do a lot of circuit board designs for fun. You can do it for like kinetic reasons. I brought just like a boring little example. This is like a steel wool tapper pad. These are like vacuum formed little nodules, like nuggets. People said that one looked like cervix, and that one I think looks like a nice little McDonald's nugget. And then there's a zip tie with a little bit of steel wool inside. You may have a little bit of floor squeeze. You can just tile the floor with these mass-producible little nubs. And then all you have to do is mass-produce a screen-printed underplate that just has all these kind of double spirals in the right place. Here's a double spiral printed on paper. You just commonly ground them if you need to. If you need to do shift registers, you probably don't want to commonly ground them. Yeah, the other plate that goes with that should be here. So here's another example of a circuit board. You know, it's just concentric circuit boarding. They're great. Some people call them like computators, but I think they're just like, they allow you to do centrifugal electrical conductivity. As long as you're aligned right, you know, you could also use it to your advantage to, you know, make a wonky system, and then things are going to fall in and out of the grain of all of these concentric loops. So it's kind of like surfing. It's also kind of like a record player, but it's a record player that's got like 16 needles. So here's that little floor panel that I wanted to remind you of. Hot glue is good enough for today. So you just have 5 leads. You can use zip wire, don't even have to do much soldering. Because this stuff you can just like use these, I think they call it, I don't know, ABC connectors, and you just like snap sieve into them, and then up to like, it's the thing that's on all IDE cables. They're like these snap ribbon cables, and you don't even have to solder to them. They're just like snap plugs that are just machined exactly know where all these little points of contact are, and they never cross over. It's weird. But you know, that's the interface, and this is 2 parts. You know, you could just control a little video game with your foot, or you put them on the walls and change the physical resistance of them, so that you can kind of push into them. But it's all just a matter of like what's underneath from the beginning. So like this little thing is just like a magic cord where you can just put your finger on it, and you're taking the energy or the drain, and that's all, you know, together. And if you just happen to rub A to B, A to C, A to D, A to E, so these are all like ends that have a wire that goes somewhere to do something. But it's cool because this thing could just be an inch wide, and you can control a row of 12 things in an inch. So that's like micro inches. Because no one wants to work too hard. Here's this concentric one. And if you just put this on a spindle, just put a hole in the middle of that, then this thing can rotate. And then you can use the concentric power. There's a couple examples of that. Here's one that's actually from the industry. And by industry, I mean like Williams, and Midway, and Bally, all the good electronic machine ball parts. This is like a complicated board that's like you know, specifically designed to make sure that you know if you're bonus 1, bonus 2, bonus 3, how many extra lives you have. Because the coolest, oldest machines, they don't have memory per se. They just have mechanical states. And this side has solenoids that have ratchet gears on them, so they can go one way, build, build. And then this one's a release, so that this spring, if it's working, it's building tension, and then once it's rotated too far, then it's like game over, and it's like boom. And then there's like these switch contacts. We've got to make sure you all know what those are. But basically they're just little prongs that sometimes they have like a micro contact on them. Sort of the equivalent of a conductive microphone. But if you use them just right, you can create tension, which is necessary for a clean contact, or a clean transition. Like they'll spend all this money to make these things called debounce algorithms that say, like, well, it's sort of a squeaky noise. It's like, was it a switch? How many switches was it? Like that happened in like half a second. And then so they'll make like an electronic filter that tries to know if it's connected or not, because like when things start to connect, just like in arc welding, you know, you'll see like this giant shock, and it's like the computer's like, whoa, okay, well I think something happened. And then after it starts, then you know it's kind of controllable. Like you hear a pop, but then you hear the rest of the word. But these were originally glued onto just a piece of a speaker grill, and that was just so that they could make a spinner. That way they could all just poke against something, like you know, the Showcase Showdown on Price is Right. How like there's just a ticker that's rotating and going tap, 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 same as on Wheel of Fortune, just like tap, 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 tap. So if this was conductive, and there's a bunch of lights connected to all those sticks, then just spinning this would make a light wave happen right there. There'd always be a light wherever there's a contact point. So it's just cool to rotate. It's linear, it's circular. Cartesian polar. Polar is like circular numerical, control, rather than Cartesian, which is like grid space. They both have their merits. Here's a hand drawn, the first one I made. I showed you it's a screen print. Most every circuit board I made is a screen print, just because I like to work in mass quantity. This one's hand done. If you feel like it, just get some glue and just like put glue down. Make sure it's dried. Experiment with which glue, because you want to make a glue that's strong enough to not falter when you dip this thing in hydrochloric acid or some kind of mixture of ferric chloride. You could dabble around with different ways. I hear there's some eco-organic ways to do it, which I don't know. They could just be get rich quick schemes, because usually you got to sacrifice your lungs or your diaphragm. Something is probably going to break if you're going to use chemicals like that. So just wear gloves. Wear a respirator. And, keep track of yourself. So this is hand-drawn and touched up in Photoshop. I don't know if you can see the purple out in television land. Macintosh is 10.6 and lower do. Here's a hand-drawn. It's like, oh, I want to make something. What does this do? It makes concentric rings. So you have 7 terminals down on the bottom, and you take one finger and you wipe across it, and then just because of the logic, wherever you see a cross is where an LED will be connected. So I don't know if I have a video of it, but you go like this, and then this thing goes. So it's like zip, zip, zip. This one's involved in a art piece that's in the background of the first picture. This is like I call it like the trucker war banner, because these are all these like trucker backwards like tow bar things. And I just happened to get like 60 of them, so I just screwed them all into some tie iron, and then these are sort of like they're like tan hides. They've got all these kind of like sinews, and these are electronic contacts that take the circuit board out to these pickups, which are just light pickups, and then they'll glow. They're incandescent bulbs, which is great. LED is kind of stupid. I mean, they're kind of you only do one way. They compromise. The incandescent bulbs, like old 6 volt, 3 volt things, they just glow. They're in pinball machines. You might just directly solder to them. They're great. They look like cans of like miniature kimchi or something. They have like a little film in them, and they're in vacuum. They're shatterable, and then you get a little bit of cloud. Whatever's in there. What is it vacuum in? But anyway, you rub your hands with the conductive gloves on the middle, and then you see this thing start rotating. So your touch turns into, like a visual element. I've got an example of something like that in here. Oh yeah, conductive glove. This is aluminum nylon. It's just been glued on. You don't need to sew if you don't want to. This is copper taffeta. This is probably better stuff because it's got less tarnish than aluminum does. Aluminum is a strange metal. But they call it aluminium if you're from like an Apple keynote. So this one's like, I just call it Clover sprocket. What does that mean? It just means that you touch these things and then like the rotation. So like you touch one and 5 lights on. So it goes like, and that's all just accomplished by just making these routes. So the first way I was just doing it was like artistic or motion based. This one's like a 180 shifter, so you press top and then you see the bottom. There's the original drawing of it. Kinetic relocation. This is a screen print based on what's inside of like a Zoom drum machine. The contact pads, they're just like these really cool like heatsink grills. This one's like a backwards forwarder, like you touch the left and then the light goes like this. But you're not limited to just flat boards if you ever get into copper laminate, which is just like a little bit of fiberglass and just like the thinnest copper foil you've ever seen, but it's just laminated so you don't notice that it's so thin. And you can Dremel it away, so you can hand make circuit boards no problem. Just get little plates of copper. I've got a bunch of scraps I can offer you if you're interested. But you always see these interweaves, It's like the double spiral or the heat sink flange, because they got to make surface contact space. like when there is going to be a carbon rub or an aluminum rub or copper rub or carbon rub or wool, steel. I think they make other steel, or they make like steel, like fabric, like steel. There's different things you can use, but they always need contact space. Here's what you see inside of your calculator. Here's what I was doing where like you send positive energy to the stuff that's beside you and you send grounding energy to the stuff that's beside you. And then if you're touching both of them at the same time, then there'll be like something that happens in between. But it's almost like making a rug. So it's strange that it's both like a primitive art as well as like an electrical concept. You can just Photoshop the ones you find inside of modern electronics. You know, you don't have to draw it yourself. There's tried and true methods everywhere. Here's one that's made for the hands. You can kind of see that the top has like finger stretches. This is like a two-sided board, and the bottom has like thumb sprays. You just draw it how you see it, and then transfer it into like hard line. Here's lights. You know, you're gonna encounter all these weird halogen bulbs or like xenon things that you know, like you'll need an inverter or a transformer to handle like what they need, and if you use them wrong, they either will explode or just not do anything. You can always just give DC voltage to incandescent bulbs, and LEDs, they work one way and they need a little bit of resistance, but you know, Sean will just connect it to like such a low voltage battery that you're like, I don't know, ain't gonna do no wrong. Back in the day when sensors were probably hard to come by, people would just pirate together a potentiometer that turned into kind of like a scissor hinge. You just put a hinge on the back of the potentiometer and then have like one piece of, you know, like slightly firm plastic connected to your body and one piece connected to your arm, and then it's the fulcrum. The fulcrum of that hinge is a potentiometer's knob, and you know, potentiometer costs 10 cents. You find them everywhere. You know about potentiometers. They're actually kind of two variable resistors, and they're the complement of each other. It's kind of a neat idea. So you never need both sides, unless you need what two at the same time, or the inverse. You know. Elliot Anderson would do this cool thing with fader knobs, where you put a spring on one side that held it like tight on open, like all the way open, and then there'd be a string that would distort the spring, and it would pull the fader all the way to the other side. So you could set up like trip ropes on the ground, and then each one of them would have like a safety switch, so that, you know, you do it right so that the ratios of the spring versus the fader size versus the material stretch, so that you don't just crack off the head of the fader. Which if you do, the fader still works. It's just the carriage got cracked in half, and you can just glue another fader cap in it. That's how I fixed a APC 40, one of those fader boxes for playing Ableton stuff. My friend's girlfriend was like getting crazy, and she just ripped off one of the fader heads. Thermistors, light resistors, anything that you can sense. The computer has a raw interest in it if you have the right sensor. I got some thermosensors out of the Thinman Lab dumpster. I didn't do it personally, but people give me things. Yeah, just like, what are you going to do with voltage? If you have a motor that's going to be handled, you know, like the simplest little things, 5 volt, 12 volt, you can sort of handle. I've tried to use relays to like multiplex like high voltages, because like the relays were like handmade and they needed like 30 volts of power to finally like contact all the snaps. Kind of like solenoids, they're like these electromagnetic grabbing pucker things, and so they just have a coil, and you give it energy, and then that coil just kind of synergizes to clench onto metal or magnetic things. So you can put a spring and a nail, and then if it's right kind of like in the reach of the solenoid's magnetic field, it'll grab it, and then that's great. And then you give it no voltage, and then it pops out. And you keep the ratios right, like the spring versus the power of the solenoid. You can make them yourself. Oh, but I've heard of cool relays. Like you can do relay logic, like when you push a momentary switch, then it can use like a momentary relay to like self self relay, another relay. So like you press a momentary switch, and then it tells the relay to snap itself shut, and then that relay will hold your push, or like it'll hold your on state. Because there's momentary and there's permanent, like toggle, like I'm A or B, but momentary is like 0, 0, 0, 0, 0, 1, and then 0, 0, 0, 0, 0, 0, 1. So you have to give them your attention. Whereas toggles are like state changers, shifters. It'd be cool if anyone had like a bunch of jumpers. I mean, dip switches. They're like these micro switches that go on board games. I mean, video games and computers. They're like these very, very small switches that are toggle, and you can get rows and rows of them. And usually they control stuff on boards like how many extra lives you have, or like what CD-ROM drive you're looking for. Sometimes you have to solder resistors differently, like to overclock a processor. Because like a motherboard we made for like 7 different kinds of processor. And if you want to trick it to think that it's a better processor, which just means like running a little bit ragged on your own processor, you can just sometimes take resistors on like a G4 Macintosh and then just switch them. They're on like a couple pins of 8 pins, and you just change them around to a different. Here's a concept of unrolling. Like you can get a linear tapestry after you roll through one of these prints. Here's a gravity sensor. I brought one. They're pretty cool. It's just a foil ball that's stuck inside of a little capture tube. Here's 2 of them. Okay, check that one out. So it's just like 2 buttons, one based on if it's falling, one based on if it's rising. And then in the middle states, you'll either get nothing or a little bit a bleed. I tried to make a bracelet that had like 10 of them in a row with pen caps and like micro ball bearings instead of this. If you do it right, you might have to lace it with steel wool so that you open up some sensitization. Here's the theory picture for just suspending a bunch of music wire or airplane wire in a grid that falls through chicken wire. And then you can lace the chicken wire with steel wool. And then you have, I call it a dangle trigger because you have all of these like steel musical wires that are dangling. They could dangle at head height so that you like walk through a space and like you feel these little things on your head. Or like, it's something that you wave your hand through like reeds at a swamp. But then all it does is that when those dangled musical wires touch the electrified fence, which they're suspended in, then, they conduct electricity, turn on a light, or control something. Here's what that looks like. Just a bunch of drilling holes and a bunch of reeds and a bunch of kind of like rubbing of felting with steel wool.
How long did that take you?
Oh, not too long. It sounded great. Sometimes these things are like musical sculptures before, and like inadvertently. Like, have you ever seen those kind of like Blammo, Remo, like microphones that just have a spring in them, and you feel like you're a celebrity because you can talk real loud with like your own reverb. So like when I put these musical wires through, you could just like pluck them and they were just suspended. Before I glued them, and they just fit right. So it's funny. Here's a electronic wind chimes. I think Wolfgang Flür was like the drummer for Kraftwerk back in the 70s and 80s in Germany, and he invented the electronic drum, which is a great idea. You don't need to fake drumming. I mean, you just take a piece of steel and you hit a piece of steel, and then like there's electricity going through, and you're just arc welding. But with low voltages and just TTL circuits and CMOS, that just needs like 5 volts, 7 volts or something. So it's not going to electrocute you. You can see there's this positive energy going into the radio antenna that I had to jangle a bunch of steel wool on to make for like conductive motion, because you need surface area, but also I had to put some chains on it, like some little lamp chain. That way it would jingle, because you usually have to compromise between sight and sound. Like you can electrify something, but that might dampen the sounds it's going to make. Here's a longer version made with like nicer steel. Here's one that would just play itself, where you just you know, you just use rudders. You know, you've seen wind chimes. You just electrify a wind chime. Just got to make sure you use, you know, conductives. Here's Bertoia columns. They're great. You just have to hold these things in a scaffolding while you cast them. Casting's better than welding. Who'd want to weld all those tips when you could just pour, like, you know, poisonous plastic goo, and then it just like turns into this like polymer steel, and it keeps them conductively unconnected. And I would just like put them into clay and then pour on top of the clay, and then just chip off the clay for those little ice crystal bases made out of like, you know, water resin. But I electrified one of them, which just meant this one down here that there's this checkerboard of electricity. So like half of them are positive and half of them are negative, the sticks themselves, and then they were wrapped with a LED, which was then wrapped in electrical tape, and then the other lead on the LED was wrapped with copper stained glass tape. And then when you rattled them, then the ones that were negative were surrounded by ones that wanted positives, and then those ones were a little lower, so that the negatives would like rattle at like the 20th inch, and then the positives would rattle at the like the 23rd inch, and so they'd both get what they wanted. And you know, who cares if you short circuit stuff, as long as there's enough stuff that's you know, still emancipated. Because like the concept of grounding is like everything shorts out. And usually people say, you know, whoa, that's wrong. I just want the ground to go where I want it to. But if you have a loose circuit, then like the first example of loose circuit I encountered probably, you know, like is just you just twist a bunch of LEDs to a bunch of resistors and just keep doing it. You just make a pile of them. And then you take two kind of like jazz brushes, just like, you know, kind of like Bertoia columns, but like mini ones for playing jazz drums. Or you can make your own with just a bunch of flanged copper wire, and you just play, like, toss the salad, and then all of the LEDs, they just have no choice but to like make you know, like conductive chains between you know, available conductive paths, and so it's really like a fractal thing. Here's a light record player. It's this first one probably was a Mr. Hack, or is a hack of Mr. Mouth, Milton Bradley board game. And all it does is just a rotating table that has a bunch of pins, like the ones I handed out. But these are not as cool as those. And then it just rubs against a metal plate that has a screen print of paint on it. Paint's just resist, or it's you know, a great resistor, an insulator. And then here's some different records that I printed on metal. And then you can just rotate them and listen to the record with your eyes. Here's a little demo picture of how it works. Here's the same thing I was talking about. It's just one of these. You just rotate it, and then like the pins on the perimeter light up the little bizarre glyph that's like a negative space with some color on it. It's cool. Sorry you can't see too well. Let's flip it. Can't see it well either. So yeah, they just rub against these little bubblegum chew balls of steel wool, and you know, it's a pretty cool, flashy show. And it doesn't even matter if it's only like a 1-inch, 5-inch show. You know, it's like something that's intricate and beautiful, like really small. Because as soon as you just put a video camera on that, then the wall is projected with it, and that's like a 20-foot installation, all based on a square inch. Here's some like corn radio ones I was making, where you know, like branch out. You know, try some speakers. So you could just have some boom boxes. You don't even need to circuit design anything. You just have some boom boxes playing noise. You have 7 boom boxes. That's like 7 signals, 14 stereo or mono channels. And then they're just all going to these different speakers. And then you, are as the DJ, have a conductive glove that just you know, channels stuff. But you know, it's hard to do mixing. Mixing, you need like some weird circuit that guards and distributes the signals together. But if they're all independent channels, you hear them all at the same time. It's almost like acoustic mixing, which is good enough. Here's some resin cores. You just cold weld, which is another word for plastic cast, a bunch of nails, and then give them all lights. And then it's like a pin board that you just touch, and then you're playing electrical rub, which is like those nail boards you get at the science store that like show you the impression based on like the textural offset relief. Yep. Here's a bunch of South Dakota Dome kind of pirated equipment. There's just like two 40-foot projector boards out in the field outside of Vermilion, South Dakota. And I just went there with crowbar a couple days in a row and just took off assembly boards that just had like, luscious plastic chips on them. They had little incandescent bulbs in them, and they were like micro small, like the size of LEDs. So what I did with them, I still have some probably, but I just resin casted them together into like a geodesic, primary solid. And it was like clear resin with a bunch of LEDs in it. I gave my friend and said, when you're ready, put this in the microwave. So here's a board, and it was controlled by a resin-casted little core with finishing nails. Super small, like 2-inch by 2-inch grid, and then look at all these wires that go gaga over this board. So yeah, it's fun to just do like little miniature wire ups. Lights, you can just wrap them. Wrapping tools, or just, find a way to do it. Twists make a lot of tension, or, surface conductivity transfer. Here's an example of like the resin underneath the nails, and how you can if these particles are clay, then once the resin casts, then the clay is expendable. You just sandblast it out, water blast it, or it comes off. And then wire wrapping. Here's a reworked this one was from Junkyard. It used to be like kids basketball. Like you have 7 points, I have 15 points. Someone's in bonus. And then, you just cut it up and then glue it together. I never done aluminum welding. You don't really need to if hot glue is enough. And then it's right now, instead of connected to like the water bowl, it's connected to a keyboard, which is, it's just piggyback technology where you have something that's cool, it makes sound great, but then you can put a light organ on it. So there's just a pad running of aluminum down the row, and then there's a Lego glued to an aluminum pad on the top. I don't even know if I had to weld anything, Solder's not really useful, just twist this stuff. And then only on the white keys, then, it plays the organ. And you make like a pinout map for like which one's supposed to go to which one. You use like these little tab stickers to like keep them all organized or something. And then just distribute the lights. So it was a little bit of weird remainder math, because we have like, 50 keys, but we have like, I don't know, like 70 lights or something. So I had to choose like, okay, well these two go here, these two go here. This one will get 3. So every key could play this, and then like as you do like a ascending crescendo thing, then the lights go. Here's a screen printing squeegee that is like for arc welding, but with just LEDs. So you just rub it across the surface. It's just like that Mr. Mouth record player, but the bottom is just a bunch of twists of copper. It's got a little surface, and then on the back, all of those twists of copper just running right up, glued to the top LED, and then all the LEDs are just grounded together, most likely. Oh yeah, I got the pinball one. Pachinko's a pretty cool game. You just have a bunch of pins. Pinball one. If anyone wants to weld, you just weld a bunch of nails to a piece of metal, and they're all conductively grounded together. And then each one of those nails can get a light that's protected with the right kind of electric tip to protect your other side. And the outside side is fuel. So a ball bounces, like you just send a little guy around here and go like this on the labyrinth game, and then as many balls as you want, just activate it dynamically, which is all you're after. Yeah, almost done with the internet thing. So this is an example of just soldering LED to 2 different pieces of copper tape, which is used for stained glass work. And then you can wrap those around stuff. Here's a picture of like the radiating electricity that I assume is inside of a bowl of electrified water. And then it slowly gets over to pickups on the sides. And then if the water is left, then the blammy power is underneath there. If the water is right, blammy power is on the other side. So I made all these like circle things that had lights in them. Like the easiest one is to say like when it's right, then the right light goes off. But then I started doing these like firework ones. Like pick up here and then like light here. Pick up here, light here. So you could spin something and then it would have like a sequence that had nothing. It was like a hardwired sequence, but it was a dynamic hardwired sequence. And if you couple that with spinning left, spinning right, spinning at different speeds, putting a couple in the same space, you know, it's a nice little bippity boppity show. So these keyboards on these pants, this is a pair of chaps. I had like 6 keyboards, and they're only soft keyboards you can get at office stores on discount because they're not fashionable. And then you just have a USB hub in your pocket, and then you can send all of these things to the same computer. There's different ways to do it. In Macs, there's like a PI object, human interface object, and that will let you like specifically decide like which one of these chameleon USB devices I'm using. So if you use that, you might have not to deal with this thing, which is just this fun little shift register game. I took these little office clamps and just connected them to shift, connected them to shift control, connected them to shift control option. That way, instead of having to use the high object, which I'm probably going to use for my thesis thing in a couple months, you know, you can just make it so that Mac sees 6 distinct different types of modifications to all these key inputs. So I had to like cut off all of the function keys because, you know, if you're doing performance art and then like preferences comes up and you're like, would you like to install show tunes? No. So yeah, you might want to gut parts of the keyboard, but ideally you make like a full-bodied outfit that had just a bunch of octopus tentacle suction cups on it, and then you could just like roll around on the floor, or, you know, and then like all that stuff is just transmitted to a computer that has some like 3D CAD of you know, you walking around in 3D super virtual space and you're like glowing and stuff. But you know, you can just put some keyboards on your pants. This only costs like 20 bucks. And then you have 400 unique controls, you know, and you can just send those all to different pitches, you know. You don't have to get crazy of like saying, I need to find 400 things to control. You can just find like 7 things to control, and then each keyboard is just like the number 0 through 100. So that's my website, like danum.ucsc.edu. On the home landing on my website, you can click on any of these things and find out stuff. I'm working on new stuff. Last time I did electromancy. Electromancy. That's the one for you guys. I did it last year when I was helping out Elliot in this class. So it talks about earth, wind, water, fire, light, metals, and then it goes into sensors. Let's see everything. Stroke, flex, pressure, thermal, there's water sensors, switches, phase sprockets, gravity, vibration, light, belt, relays, solenoids, belts, gears, cams, and then down to conductives. Paint, copper wire, foil, bearings, laminate, chicken wire, brads are cool. Nails, plastic, foam, fabric, resin, spring, fastener, music wire, copper pins, glove, and then down to techniques, which are bigger words that look kind of like bubble gum. I like those ones. And then here's just a description of all these different projects that are sort of, you know, already apparent to you. I think I put in stuff I did like last fall, but you know, once you kind of finish a project, you just, you know, don't care about it. Do the new one, which is called genealogy. This one's great. It's great. It's got like 100 20-frame animations that stall the computer's mind until they're all loaded. Yeah, so I'm doing like software stuff for fun. Because I told Peter Elsey over at the music department, like 5-10 years ago, you know, he's like, if you're not independent wealthy, you got to get a job. I'm like, oh, yeah? It's like, what kind of job would you want? And I said, I want to be like a video game theorist. So, you know, if you're going to do something, you got to do it. Who cares if you get paid? Let's check out a couple more things in this bag. So this guy is like a, like, you know, it's different variations. You have these like rotating things, and then there's just like this one piece of steel wool on a ribbon that's rubbing from the middle to the ground. And then as it turns, only the stuff that has one of these, half crescents, each one has a window of opportunity. And then it's supposedly all of them are on a bar, there's the center of it, so it's spinnable. You can have propeller spin for you. And then this core has just a bunch of lights. So like 12 lights, 5 of pickups. So like some of the pickups have like 3 lights, some have 2. They might be completely disorganized. You can do color code it, and all of a sudden it's apparent what it is. Because it can look confusing, it's just a bunch of wire. And you have to visually go from like one place to another. But if you start stockpiling wire now, they make it like 15 different colors if you look hard enough. Underneath, the first thing I got me interested, like I've got like 20 electronic organs, like Baldwin, Kimball, Wurlitzer, Lowry, and same old thing. They've got these conductive tabs, and they're all going to the same bar. So like bar's got energy, and then all the tabs are like, I need energy, and this is like do, re, mi, fa, sol, la, ti, do, and then like you're actually touching like a piece of plastic out here because you're like a musician from like Beethoven's generation. But it's kind of boring. You just got your keyboard, and then just take this and do that, and make music like that. And it's obvious that we don't need these outdated interfaces. And then there's this one wire right here that originally was soldered to the strong bar. So like this pinout, just by looking at it, you've got all these pins, and then like just you look at it and say, oh, okay, pin 10 is ground. The rest of them are unique. Springs are great. These aren't springs, but they are. They've got tension. They've got return. But another way to do it, this is probably from a Kimball organ, is they have a parallel channel. So like this guy right here might bounce, and then all the springs in this row would sag against a bar. So in that way, you could put as many of these cool little springs in a row, and then just push one shelf, and then they'd all tap, they'd all do their thing. And they could all be independent, You have bars with energy or feeds, and then you have as many strings as you want in a row. So these guys are used to say like, I want tremolo, and then tremolo says, well, voice 1's got to do this, voice 2's got to do this. There's nothing on voice 3 today. It's like, I want Hawaiian guitar. It's like, well, voice 1's got to do this, voice 2's got to do this. What voice 2 today? So they're parallel lines. If you ever get into just like the idea of pull and throw, so you could do art with like 100 throws, or you could do art with 100 pulls, and just divide with like strange multiplices, which is probably the way to go. Sometimes you just need some rubby material. Like I got a hoard of pads of foam, for mice, and then you just grab a scrap, and then you can make a flex sensor out of it. There's this cool trick to make flex sensors with cheap material, where you make like a barbershop diagonal on this one, and then you make the complementary barbershop diagonal on another one, and then you put them together. These ones wouldn't work. No. These ones would cross like a hatch. You don't want that. But yeah, you just make a stack of clockwise and counterclockwise, and you touch them together, and then it'll look like this. They won't be touching. And all you have to do is take a piece of Velistat, which is like this black tarp stuff that you can get from 3M. I've got a lot of it, but what it does is it's a variable. It's like a semiconductor that's used to make stop alien mind control helmets, which is useful if you lay out like 7 in a row and you can't hear radio waves inside your head. But more to the point, it's a semiconductor, so you put it in here, and then those things that aren't touching but are close to touching have a chance to slowly kind of okay, we're radiating knowledge of each other, which just means there's a resistance between the two instead of perfect insulation. This is like from a Kauai organ. You know, it's just a nice little interface. Like, what is a piece of art that you like to do? Like, well, I want to have inputs and outputs, and I want to have control of the volume. You know, everyone's dream is just to have control of the volume, like be able to say something, and be able to hear something, and then like, well, not today. I don't want to talk. I want to channel like my favorite radio show. So think about your art. Like, I've seen some great stuff when I was in New York. This guy that he did, like, his name is Michael Fry. He did like a musical performance where he takes shoes and spray paints them gold, puts them upside down, like nice loafers, and then plays them with contact mics inside of them, and then just plays them with drumsticks. And then when he wants to really DJ, he takes his car wheel, which is just like an endless potentiometer, and so he's just up there with the bottom of shoes bopping out, and then he's like controlling pitch of his max patch with his steering wheel. So he's like driving on stage, and you know, it's kind of absurd.
How do you make an endless potentiometer?
It's actually just like a pulse wave of ticks. Do we have like stuff to draw on the board with? Thanks. If you make a dial that just has like a bunch of bumps in it, what you could do is just have like a power right here, and then have like two pickups on the left and the right, and then every time that like this bump is gonna move left, then it's gonna tap this one, and then pop back to the middle, and then all you do is keep track of like left moves or right moves, and then you just do ink deck, which I think I gave to Sean, but it's just a little device of like, well, when I, like two bangs, if a bang comes in the left, then take the number and minus one from it. If a bang comes in the right, take the number and add one to it. So it's like bang, 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 builds it up, bang, 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 builds it down. And then you could have a third number box that just changes like your feed so that minus one and plus one, you know, turn into minus two and plus two, minus two and plus three. You know, that's like your modulator. Do anything you want. But yeah, just to get your endless fader, because no one really wants to be limited. But then as soon as you have an endless fader, you got to think about what are you going to do with endless sound or endless motion. Well, gee, that's hard to use. So if you have like a 640 by 480 screen and you're trying to do like a little turtle graphic, and you got an endless fader, you're controlling your 640, you're going to go over here and you're going to lose sight of your art. It's going to fall off if you do that. So what you can do is actually do a 1280. Focus on like a 1280 world, and then do like a minus 640 from it, and then do an ABS to it. And then what you end up doing is you have like 640 down to 0, and then up to 640 again. So like if you just kept fading, then you just start doing this. And since 640 and 0 are the same thing, or sorry, 1280 and 0 are the same thing in this little equation of, you know, the world split between the 640 ABS, absolute value, then you'll just get this eternal graphic that goes back and forth. You could do it on X and Y. And that way, like when you do an install, you don't want things to just break themselves. They have to be, well, not bomb-proof, but just maybe bulletproof. Because the worst thing is you show up on the scene and you're like, hey, installation, are you okay? And then you check the scene for safety, and then listen for sounds of life. You know, it's a lot of work. When you could have just made sure that they could auto resuscitate themselves. So let's see if there's anything else in this pile. Here's a cam. This isn't a very obvious. It's a little bit spiky for a cam. But the whole idea is, like as it turns, this thing rides on the top. So it's sort of like a little bit of variable motion detector. So if you did have a potentiometer over here, then it could be like when this is turned that you get a periodic wave. And then any spatial cam, could be like an oblong eggshell. I think like the limits of cams are like there's always a center. And then you say like, well, let's just make a 3-sided. Let's make a 4-sided. Let's make kind of like an oblong one. But you got to think of like the center and then the max height. And then you can do anything inside of there, but if something's too abrupt, then like a lever will get snagged on it. But you could do like a pop-up one. But then you start making art that can only work in one direction. And as soon as someone that doesn't know that gets to your art, they'll break it. So you could use like a ratchet. Some bikes, like you can turn it all you want forward, and then it's like, doesn't work backward. But this is a snap of copper laminate if anyone wants to play with it. This is like a hand-cut circle, so I had maybe had like a circle plate that was huge. I don't even know. And then I always had these like little triangles on the press corner that, I don't know, I wouldn't throw them away because they're so useful. But when you sat down to make a new piece of art, you never really say, what am I going to do with those press corners? You're more concerned with like the whole enchilada. Just keep a track, an eye out for water art. I mean, there's pumps and lots of stuff. I once got like a dental delivery unit from the back of the Trader Joe's, and it had like this weird vaporizer that like lets you do like aromatherapy with like stuff that was like suspended in water. They would just like steam up the house, like a humidifier. I don't know why they had that as a dental. But otherwise, there's this attachment you can make for a pump or for a motor. It's you'll see them in like ink massaging printers, where you just need something to rotate. And what you need to rotate is a cam that looks like that. And then you just have like your tubing. You might like siphon it so it has something to start with. Because once like a tube has some stuff to start with, then it can kind of pull itself up. Sort of like capillary action. So you have it enclosed in something, and then when you turn the motor, it'll start pushing this stuff out. So like as I said, like the maximum amplitude of the turner, keep it on the inside like halfway through, it's like micro tune it. And then like water will start getting suctioned up and pulled through at the speed of this motor turning. And every time the motor turns, water will get re-enter, and then you get like this much water on every revolution. And they're hand-madeable, or you can find really nice, like almost like they look like steam engines inside of certain electronics, like compressors. But a lot of times, like compressors will just have like a funnel vortex. If you ever seen like a squirrel cage fan, it'll almost be like they're like the gate to get into Magic Mountain, where it's like you are allowed in, and then like beside it's like you are allowed out, and it's like, well, what if I'm sort of like want a gate crash? Like, no, because that's how you need to make like a vacuum. You need to like have some hermetically divided space. So this is where stuff enters, and this is where stuff goes. And there's this weird rule about like canyons always have wind, because like say this is a bird's eye view of like the Grand Canyon. For some reason, like a force of air in a big space, it could be slow, but if it encounters a little space, then everything has to move fast. There's probably a good reason for it. So like sometimes a squirrel cage fan will be kind of like a cornucopia, and it wants to have the stuff enter from a broad space into a narrow space. And then by the end of it, then the output is just like a little spigot. Oh yeah, but practically the same thing's going on with offset motors. Like here's a back massager, and you gotta be careful. Like if you manually simulate a motor, just don't touch those, because you can electrocute yourself with your own kinetic force. I'm turning this, and then if that's touching you, it's like, ow, ow, ow. But this guy is a little similar. Like if you watch it, it's got an offset. So you can imagine to control a little bit of water pump, you just have like a tube on that side that's kind of like vacuum, kind of like, I don't know, like nipple sucked out or something. But, this is a great piece of something. Well, probably the best piece of electronic art I'd seen at this campus was like 10 years ago. Some guy connected like a reciprocating saw or a drill to like a a piece of metal that kind of looked like a butt of a girl, and she's like wearing like rhinestones. And then you go up to it, and there's like this grabber that's like a gear shifter, and then the gear shifter is just connected to the drill down there. So like you pull it, and then like the body just starts going like this really fast, and it's just a bunch of janky metal, and it's just great because it's just it's high power. You know, a lot of guys are working with 5 volts and working with computer screens, but like those guys at Survival Research Laboratory, they wouldn't even say what I think is enough volume is anything else, because they're using a kinetic system where you're launching tons of power, pressurized mass. They have a 2x4 launcher, and it's like computer controlled on the internet. So if you go to the 2x4 website launcher, you can go to it, and you have like collective control of like the targeting, and it's it's out in Kansas or something, and all it's doing is it's got like a bunch of car tires that are at high RPM, and then it's got like a front loader that brings the new 2x4 in, and then you control like the XY axis of it, and then it just shoots it off into this kind of like metaphorical space, which is actually in some giant field with some warning signs on it somewhere in there. So it's kind of tall presence. Another really cool spring switch. You can do anything with springs. You put a wire in a spring. If you ever open up a stereo 1/4-inch audio cable, they've got the lead wire, say positive, and then that's got insulation on it, because everything's got insulation. And then outside of that, it's got a crossweave of the copper that is the negative, say. So regular 1/4-inch is like one of those bishops, and one goes to the ring, one goes to the tip on the inside. But this wire itself, if you sheath it, and then of course that's insulated. If you sheath it, then you have, from cross section, you have like energy, and then insulation, and then you have weave. So what you can do is just take a little 2-inch piece of that and put it inside of a spring. And then whenever that spring is pushed, you have to like firmly glue the wire to the top and the bottom, and then it's taut. I guess it's same height and stuff, and it's under tension. And then all you have to do is push the spring down. You could put a button on top of it and put it in a socket so that it can't go crazy offset. And then you push it down, and then the wire that was originally taut in the middle, it has no choice because of its length but to bend. And once it bends, it touches the spring. So the spring is soldered to somewhere, and the outer rim is soldered to somewhere else. And then there's also this other piece of wire that's going through the whole middle of it. It's not even needed if you didn't need it. But I think that was useful when I was trying to do it. Another way to do spring art with electricity is you electrify a spring and you hold it tight over a precipice. Oops. Precipice means nothing. And then down below the precipice is a tab, which is a pickup with a wire going out to it. So there's a wire going to a spring, and then there's a wire going to a little pickup contact. Just any kind of metal. And then the user either can touch the spring directly, or you can put a pad over the spring. So they can touch anything you want, and then just make sure it's kind of floating in space. And springs will help you float things in space. And in this fashion, you could suspend a spring here, a spring here, a spring here, a spring here, and then have like 5 buttons hidden. And then you just roll some neoprene or surfboard wetsuit material over the top. And then the person just is kind of rubbing against the surfboard material. You could put kind of lumps like eggshells in it, anything really. But then that surface itself becomes like it's kind of intangible. Like, you know you're controlling buttons. You don't see the buttons. You're like, am I making electronic art? Like, you don't know. You're just pushing a switch or something. Is probably more obvious or more neutral than, you know, having like dental tools in your mouth, like clamps, like, you know, technology. Like, I'm going to use a Kinect. Like, instead it's something that we've been doing for thousands of years, just, you know, touching something. So in this case, you're using the springs ability to bend into that surface. In this case, you're using the springs compression. Like, it's not bending necessarily; it's compressing, and then using the bend of the inner wire. I like these diodes a lot. The little orange guys with the black heads. And they're just like the easiest thing I understand. I don't know much about capacitors. I mean, I don't know how to party with capacitors. But a diode, you know, just a blocker. There's certain logic gates you can get from blocking. You know, if you take logic, truth-false tables is usually about like you have two switches, and then you have a result. So like the OR is like this switch is on, but this switch is off. On and off both start with O. That's not good. Plus, minus, and then your output. If it's an inclusive OR, then it's cool. It's on. Minus, plus, it's on. Plus, plus, it's on. Off, off, it's off. That's the OR table. I think that's the inclusive OR table. The XOR table is a little different. It changes to one or the other, but not both. So the AND is no longer involved. So the ANDs table is nothing across the board. AND's the pickiest. And 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 exclusive OR are the opposite of each other. And then there's like these weird ones like fallacy. Like, like what if you had one that is just wrong? Or there's like the pass ones. There's like a component of pass. Like whenever the left one is on, then it passes. And that's almost like it doesn't even care what's in the second row. It's like a null set. But there's going to be a weird one, because like your output for your tables, I just like logic possibility. But the coolest thing you guys are doing maybe is working with Max. I think Max is a sweet tool. I've used it for 10 years. I don't really care much to connect the material world to it. I mean, you got a mouse, you got a keyboard. That's amazing. That's pretty good. I mean, musical instruments are great too. They have stuff in them. But I don't know. I never caught on to the whole microprocessor. Like, I want my computer to talk to a baby computer, and then that baby computer's gonna go out there and like tell daddy, like do daddy's work for him. You know? It's like computers can do anything. Like, why are we always like let's make a computer that can fit in your ear? But I can hardly imagine reaching out into, I guess, I don't know, they've been doing it since the 70s where you're wearing a wireless controller and you're dancing, you know? And that's on the screen or it's making sound, you know? Like you, yourself, your body, without even your choice, have a biofeedback. It could be as simple as a blood pressure monitor that is audible over the room. I think it's maybe a tool to like sensitize people to their environment, self-awareness. So, I mean, anything in the name of self-awareness, right? But I don't know. Part of my art these days is probably about sensory overload. So one of the pieces for my thesis in a month or two is just a bunch of mice that are glued, like the infrared mice that are glued to the bottom of a giant trackball. And then like you're controlling like 4 computers. It's like you can control as many computers as you want with one motion. And then each one has a little different of a tangible acknowledgement of your control. Just a bunch of glued mice. Like mice are free, you know? They're XY, they're click. That's amazing. Buttons are free too. Any two pieces of metal touching each other. Here's the front end for changing to all my presets on my Kauai organ. And they give you rules like switch steps, which you can totally emulate. Like, I think the coolest thing you can do in Max is take like your favorite piece of hardware you ever seen, like if you like a drum machine, and then just like put the picture of the drum machine inside of the computer, and then like architect like the piece of hardware into software again, and then be like, and then throw away the original. It's like, I don't need this. I have a virtual one. But yeah, but like there's logic for this, which is like if I'm playing it and I've done my presets, and then I click right and then press 3. That means that from now on, whenever I press 3, I'm going to that preset. I don't even know what the preset button is. But just like staying with the keyboard pins, it's like if you have limited buttons, say you have 6 buttons, what could you control? You can control 6 things, or you can control 5 things at a time, and then this is your toggle, or this is like your evolve button. You know, like in Max, it's called cycle. So like I'm on 5 of the first things, and then I press this, and like now I control 5 other things. Press this, 5 other things. So think about it. Then you have 2 buttons that control what control you're controlling. So you can just exponentially turn any number of choices into that many more extra choices if you use buttons in a meta way instead of like as original. Like, you know, they don't do anything. They just change what you're about to do. And that kind of stuff in the beginning probably just existed on the back of those mechanical boards. This guy's so cool. It's a visual logic. And when you look at this, you can say, is it broken or not? Because broken would mean that like this is not touching that, or that like one twisted out of the alignment. But it's a different place to look. Like you can buy a kit for $100 that has like the micro tools that ITT Tech wants you to build on, or you can just harvest things that are around, and you can even call yourself like a rescue orphanage for the demented youth of the technological Leviathan. I think we make a lot of movies about that, where like some alien or some Johnny Five shows up and he's like, I'm a broken machine, and then like people are like, well, that's cool. We live in technoculture. We'll help you out, but we'll keep you a secret. Wouldn't want the NASA people getting hold of you. Yeah. So I don't see anything cooler down here. This is a pretty cool size speaker though. You'll find sizes. Like you can't find this. We should, if anyone is wanting to, I got a whole desk of nonsense over at Danum. It'd be a great opportunity just to flood in there and confuse people.
Cool.